There are two fundamental reasons to suspect that the reaction rate should depend on the temperature. First, the collision rate depends on the temperature because the relative velocity depends on the temperature. Secondly, the reaction will only occur if the collision happens with enough kinetic energy to overcome the potential energy barrier and get to the transition state. Therefore, higher temperatures will result in higher energy collisions and lead to more reactions or more frequent reaction. Therefore, we expect temperature to affect the reaction rate. The reaction rate is proportional to the concentration, a power law in the concentration of reactants. The concentration of reactants are not temperature dependent, and therefore it is this proportionality constant, or the rate coefficient, which is dependent on temperature. Experimentally, we find that this temperature dependence is exponential. You are no doubt familiar with this Arrhenius equation for the rate coefficient. Notice that if we take the natural log of both sides of this Arrhenius equation, we find that we can express this in a straight line form, where y is equal to the natural log of the rate coefficient. The y-intercept is the natural log of the so-called pre-exponential factor. Our slope is minus e over r, and our x value is 1 over t. Thus, if we graph the natural log of k as a function of 1 over t, we expect to get a straight line with a negative slope. The slope of this line is the activation energy divided by r, and the y-intercept is the natural log of this pre-exponential. And this is how we would measure the activation energy for a reaction experimentally.